So now we've talked about enough already in this unit to talk about that thing we call the heat index or heat index temperature. It's the feels like temperature when it's summertime. It's that thing that makes you feel potentially miserable. So in order to talk about the heat index temperature, the temperature that actually our bodies feel like it's at, we needed to understand this idea of relative humidity and a little bit approaching saturation. So in order for this to make sense, is the closer that a box or a system comes to saturation, so say we're at 90% relative humidity, then actually the rate of evaporation, remember what evaporation is, it's this liquid to gas, the rate of evaporation decreases, it slows. But remember, when something goes from a liquid to a gas, that actually is what we call endothermic, and we talked about these terms, endothermic, and it requires energy, so I'll put E is absorbed, okay, in order for that to happen. And so the way this works with our human body is this, and I kind of have a series of kind of talking you through what this looks like. So here is my rendition of somebody's arm. I know it's kind of a very strange arm, and we're gonna say it's a hot, muggy day, and we're gonna say that this person starts to sweat. So that's a big old pile of liquid water, okay? Now, the deal is well, let's just say it's a dry day, okay? If it's a dry day, what's going to happen, if this is liquid, is this is going to go ahead and evaporate, okay? And as it evaporates, it zaps energy, or it requires energy, and basically it gets the energy from this guy's or girl's arm, so energy. So energy is drawn out of the arm, okay, during this whole, what would this be, evaporation process, okay, and it makes the person feel happy, okay, because they are cooler, they literally are cooler. Now let's go ahead and draw a similar arm. I don't know how I could draw a similar arm. That's my similar arm, okay, and we're going to go ahead and make this a high relative humidity day. Okay, and the person is working, and the person creates a sweat. Here's the person's liquid, okay? And now we're going to go ahead and we're going to go ahead and let Mother Nature do its thing. Basically, we have energy here that wants to be drawn off because this person is hot, okay? But the rate at which, so I'll try to draw a smaller arrow. I don't know if that's much smaller. Okay, since it's high humidity, there's already lots of water vapor up here as compared to over here, okay, then the rate is less. So what's this? Well, this is evaporation, and since this is less, we have less cooling effect. I hope that works for you, because that is the real deal, less cooling effect. Okay, so then the way this works then is we have this table over here. This is a heat index table. And so what you do is you pick up, so we could be at 90 degrees, okay? And then for instance, let's say we're bumping up 80% relative humidity. We can go see where those two intersect, which, wow, okay, I'm getting 113. So then 113 would be your feels like temperature. Ooh. That would not be good. Oh, one other thing before I leave this is, so the way I've described, does this make sense that only like biological creatures that count on sweating and the water evaporating to cool them down, only biological creatures like this can feel heat index? So in other words, your car radiator does not feel the effect of humidity on, and it creates a feel like temperature.